Hello everyone. We are going to solve some of the gate problems today. So if you see question number 1, a circular pile of diameter 0.6 meter and length 8 meter was constructed in a cohesive soil stratum having following properties. The properties of the soil is given as bulk unit weight 19 kilonewton per cubic meter and the angle of internal friction in undrained condition phi u equal to 0 degree. The undrained cohesion is given to you as 25 kilopascal. Allowable load the pile can carry with a factor of safety 3 is to be calculated. So whenever such problems are there, to understand, I would like to draw a circular pile over here. So this is the circular pile. This pile is embedded into the ground, and this ground is having the properties that are given over here. These are the properties of the ground. These are the properties of the ground, and it is cohesive. So this is cohesive ground, and the properties are given to you. You need to calculate the allowable load carrying capacity of this pile. The factor of safety is given to you as 3, and the diameter is 0.6 meter, and the length is also given to you as 8 meter. So in a cohesive bed, when the ground is cohesive in nature, how to calculate the allowable load carrying capacity? So the formula for allowable load carrying capacity is QU, the ultimate load carrying capacity, divided by a factor of safety. And the ultimate load carrying capacity of this pile is given as the unit skin friction that is going to develop along the pile shaft is called Fs into shaft area plus the unit end bearing resistance into the area of the pile at its end or at its tip. For cohesive ground, the value of Fs is going to be alpha times Cu, and the shaft area is going to be pi d into L. So you can calculate it. So alpha being given over here, what is the value of alpha? It is given in the problem. The diameter is given to you, length is given to you, and the alpha value is not given over here because the Cu is less than 40 kilopascal. So you can assume this alpha value as 1. So multiplied by 25, so it is going to be 25. So Fs is going to be 25, and this is going to be pi, and diameter 0.6, and length is 8 meter. So you can just calculate it. So you can take the calculator and calculate it. So going to be 15.07 meter square, and this is so much of kilopascal. So this has been similarly. QE will be 9 times CU. So 9 into 25, this you can calculate it. So it becomes 225 kilopascal. So then area of the pile at its end will be pi by 4 into d square. So this also you can calculate it. And when you substitute it, you will be getting the value of QU. So let us substitute these values so that we get the value of this. So the ultimate load carrying capacity of this pile is going to be 25 multiplied by 15.07 plus QE is 225 kilopascal, and area at the end, this you can calculate it, pi by 4 into d square, 0.6 whole square. So let's calculate this. So take your calculator and calculate it. So this is going to be multiplied by 25 plus 225 into y multiplied by 0.6 square divided by 4 equal to, this comes out to be 440.608 kilonewton. So this is the ultimate load carrying capacity. But in this question, you have been asked to find out the allowable load. So allowable load is going to be 440.608 kilonewton divided by factor of safety 3. So this gives you divided by 3. So this gives you 146.86 kilonewton. So that is the answer of question number 1. You can solve it very easily in the examination. In the previous video also, we have given you the theoretical background for this. Now we will go to problem number 2. So now problem number 2, that is also gate question that we will see how to solve it. So question number 2, let us attempt. Question number 2. So solution of question number 2 we will see. So question number 2, a timber pile. The pile is made of timber. Length of the pile, so let's say this is the pile which is made of timber, and the length of the pile is 8 meter as shown, and diameter is 0.2 meter. Diameter equal to 0.2 is driven with a 20 kilonewton drop hammer. So the weight of the hammer WH is given to you in the problem as 20 kilonewton. So we know the weight of the hammer. Falling freely from a height of, so height of fall of the hammer is given to us as 1.5 meter, that is 150 centimeter. The total penetration of the pile in last 5 drops. So total penetration is also given. So totals, you can calculate the set. Set is going to be 4 centimeter. So 4 centimeter divided by number of blows. that is 5 blows. So divided by 5, that is 0.8 centimeter per blow. That is called set. So we can calculate this. Use engineering news formula or expression, and there the factor of safety is given to you as 6, and the empirical factor C is given to you as 2.5 centimeter. So this is also given to you, and you need to calculate the safe load carrying capacity of the pile. So the safe load carrying capacity of the pile QA in kilonewton will be the weight of the hammer multiplied by the height of fall divided by the factor of safety into this set plus this empirical constant. So if you just substitute all the values, this becomes 20 kilonewton, height of fall 150 centimeter, factor of safety 6, this is 0.8 plus 2.5. So it's simply, if you calculate, within no time you can get the allowable load carrying capacity in kilonewton. Let's calculate it. You also calculate 20 multiplied by 150 divided by 6. Is 151 point is coming out to be 151.51 kilonewton. So this is the answer. So this is how you can attempt these questions, and you can solve it very easily. So the basic formula and expression, if you know it, the allowable load carrying capacity from a static formula and from the dynamic formula, you can calculate it quite easily. Thank you.